We want to look at how do we measure covariance and correlation in Stata. We'll start with correlation. If you want to see the correlation between two variables, say x and y, then the syntax for that would be you will write CORR core, which is short for correlation, XY, or you can write correlation YX. Order of x and y doesn't matter. It doesn't matter whether you write correlation XY or you write correlation YX. So let's look at an example from the auto data set. So if I want to find the correlation between price and MPG, so we'll do correlation price MPG, or you can do correlation MPG price, doesn't matter. Oh, sorry, CTI plus T. So now over here, a couple of things to notice. So Stata is showing this correlation matrix between price and MPG. One of the properties of correlation is that the correlation between a variable and itself is 1, right? So we can see over here that correlation between price and price is 1, correlation between MPG and MPG is 1. Another property of correlation is that correlation between x and y is equal to correlation of y and x. That's why we also said over here the order of x and y does not matter because the correlation between x and y is the same as correlation between y and x. So correlation between price and MPG is the same as correlation between MPG and price, which we can see is minus 0.486, which is why Stata only displays one of these, right? So Stata has only showed this correlation over here. It hasn't shown this because they both are equal, right? Correlation between MPG and price is the same as between price and MPG. So Stata does not display this because they both are equal, right? So two things to note in this correlation matrix is correlation between a variable and itself is 1, as you can see in the diagonal entries of this correlation matrix. And because correlation between MPG and price is the same as between price and MPG, so Stata only displays one of these, right? Which you can see is minus 0.4686. Now, what if you have more than two variables and you want to find all the pairwise correlations? What I mean is if you have three variables x, y, and z, we want to form their correlation matrix, which tells us the correlation between x and y, correlation between x and z, and the correlation between y and z. So, given more than two variables, we want to find all the pairwise correlations, the correlations between any two of these. So say we want to find the all pairwise correlations between the three variables x, y, and z. So we will just do correlation x, y, z. Again, the order does not matter. You can write it in any order. You can write order x, z, y, z, x, and so on. So now let's say we want to find the all pairwise correlations between price, MPG, and weight. So again, we can see, okay, we look at the first property, the correlation between a variable and itself is 1. So correlation between price and price is 1. Correlation between MPG and MPG is 1. Correlation between weight and weight is 1. So the diagonal entries of this correlation matrix are all 1. And then you can see the off diagonal entries show correlations between any two of these different variables. Correlation between price and MPG is again minus 0.4686 because this is the same as correlation between price, because this is the same as this, so Stata is only displaying one of these. Similarly, the correlation between weight and price is 0.5386, and because this would be the same as this correlation between price and weight, Stata is not displaying this. The correlation between weight and MPG is minus 0.8072 because this would be the same as the correlation between MPG and weight, Stata is not displaying this, right? So just, and if you wanted to find all pairwise correlation between four variables, right? So you could just write all of those and Stata will show a correlation matrix showing the correlation between any two of those, right? So the correlation matrix, the diagonal entries are 1 because the correlation between a variable in itself is 1, and Stata does not display the entire matrix because we know of this property, correlation between y and x is the same as correlation between y and x and y is the same as correlation between y and x. So if you know the correlation between weight and price is this, so you know the correlation between price and weight over here would also be minus 0.5386, right? So next part we'll look at how do we measure covariance.